Okay, how you doing, everybody? This is definitely going to be a little bit different today. We are still trying to work out some logistics on how to get Skype into Procaster. If there was a Mac, we'd be able to do it, but this is a PC, so we're having issues, so we're going to do it this way. By the way, you notice on your screen, that would be Tony Reynes, and Tony is a meteorologist at the National Weather Service in Ruskin, and we are getting a lot of folks who are already asking questions about the upcoming rain event and also the upcoming tropical. Now, this is more of a tropical weather situation to start things off. We talk a lot about models, and I'm getting a lot of folks already asking me about that. But we are we're actually asking people, Randy, we're getting people from Ohio. We have people from all over the country, and we even get some international viewers from time to time. So, Tony, how long have you been at Ruskin?
Right now in the weather service in Tampa, I've been 6 years.
Okay, and what's your background?
Well, I started as a volunteer in the National Weather Service in San Juan, Puerto Rico. That's where I'm from. And then from there, in Puerto Rico, I did the bachelor's degree in physics, and then I moved to Hawaii, University of Hawaii, where I did the master's in meteorology. And then from there, I went back to San Juan. I started my weather career there. Then I moved to El Paso, Texas, where I worked for 2 years. And then I moved here to Tampa, where I've been for the last 6 years.
Well, as all my part of the webcast, as all the viewers out here know, I'm very high on the National Weather Service in Ruskin. I think they're as strong of a group of meteorologists as I've ever worked with. And as I'm looking right here, Randy, Daryl, Danny, Shelley, Kim, Matthew, Stephen, Joey, the list goes on and on. They're all saying hello. Now, again,
Thank you.
Tony is not seeing the your questions scroll up, so I'm going to relay them as we go. But at some point in time when you log in through Facebook, maybe you might even want to hit refresh. If you actually hit refresh on the monitor, on the laptop, it might start popping up with names, because that's happened to me from time to time as well. I didn't get anything until refresh.
Okay.
And by the way, and just in case everybody, the one thing that I think we're going to have to do when we finish with Tony, well, you know what, I was going to say we would continue with Procaster, but truthfully, we don't need to, because everything that we're going to talk about tonight, Tony is going to lead the way with us. So anyway, so why don't we just take it in this format and we'll go from there. So I'll tell you what, why don't we start off and we will go with the topics. And I have on the NHC's page, as you can see, there's NOAA, and the National Hurricane Center page. We will pop up right here. And I'm guessing you can see this, or I will just follow along. You're probably a little bit of a delay, I'm guessing, of what you're seeing compared to what I'm doing. But what about this area in red? We've been talking about it for days now. What's your take on this?
Well, this is interesting, because this area that you see there, it's what we call a strong tropical wave that came from the what we call one of the easterly waves that come from Africa. And what is interesting about this system is that it has what we call all the ingredients. They all came together rather quickly. Sometimes these tropical systems, they may start with a strong tropical wave, but they don't have the surface temperatures of the waters that are ideal for the system to develop. They have to get a little bit closer to the Western Atlantic. And then the other ingredient is the upper level winds. This system actually has all three ingredients in place right now. They all came together. So we now are seeing that there are some, the structures of the thunderstorms are starting to look like spiral bands. You have the surface temperatures over the waters that are becoming also favorable. They're like over 80 degrees right now. And it seems like the system is actually starting to spin. So a low level circulation is very likely it's actually forming right now. And that's why they're putting this system with a 70% chance of development. And that is very high. Once you go above 60, the chances of this storm, of this system becoming a storm, I would say within the next 24 to 48 hours are very high.
Now, if you see, Tony, we're showing the, I'm guessing you can see the viz, the loop
Yes.
here. And, you know, it certainly doesn't have the look of a classic system, but everybody can see there's certainly the turn that Tony's talking about, and the rotation as it starts to to get its act together, I would say.
Yeah, and you're absolutely right. You said the right words, Dennis. It doesn't look like a classic system yet. That's why they haven't named it. But as soon as you see that center becoming more tighter, as soon as the hurricane center specialists, as soon as they can identify a very well-defined low level of circulation, and if you look at the left-hand side of the system, like the left quadrant, there might be a little bit of wind shear there because you can see that most of the strong cloudiness, it's all tilted to the right of the system.
Mm-hmm.
And on the left-hand side, you still can see the signature of a little bit of wind shear in the upper levels. But they are saying that that wind shear, it's very likely it's going to relax within the next 24 hours. And that's going to be the key for this system to become a storm.
Tony, tell everybody how, in terms of, and I think this is interesting, a lot of folks don't realize that it isn't always flying into a storm getting the readings. When the storms are this far out, they use a method to determine whether or not they are showing tropical storm winds using the DVORAK scale. Could you explain a little more about that, what that is? Because I've actually never talked with them about this.
It's satellite-based. It's all satellite analysis. What they do is they have a very huge database of storms, and it does several things. There's several analyses that the DVORAK scale does. But one of the main things it does is basically makes a comparison of systems that were similar when they were being in this stage of development, deposition, and also they have very powerful analysis methods that tells them how fast the clouds are moving based on the turning that they're seeing on the clouds. They also calculate on what's the radius of the maximum winds that they're seeing on satellite. And it's a very, very powerful tool because it combines a multitude of different calculations basically simultaneously. And then it makes a collage of all these information, and it compares it to a very, very extensive database of previous storms.
Now Tony,
correct.
So when you're looking at that, if they come up with a DVORAK scale of 2, that would mean the winds are 30 knots, which
Yes.
If that were the case, they would go ahead and deem this a depression? If there was,
Absolutely,
right,
yes.
okay. All right,
Yes.
so again, I've never actually shown this before. We've never really talked about it. So in your memory, what's the highest DVORAK scale that you've ever seen in terms of a hurricane?
The highest I've ever seen on the Atlantic, it's been a 5.
Okay.
Because what happens is that normally when they are reaching when they are on a 4 and a 4.5, they know at that point, then they have to start to do the flights. Because after that point, after the 4 scale, it's the resolution of the DVORAK scale is just not as good.
Mm-hmm.
So DVORAK is very good when the system is out, which is far from land. You don't want to still use the resources of the hurricane hunters because we all know these are very, very expensive resources.
Mm-hmm.
The hurricane hunter flights, they consume a lot of resources. We don't have observations over the ocean, of course. We only have 1 or 2 buoys at best, always available in the vicinity of a hurricane or a storm. So they use DVORAK up to the 4.5 number. If they see that the DVORAK is close or is going to hit 5, then they move into real observations with the hurricane hunters.
Okay, Tony, thank you. We're going to go and look a little bit. We're going to look at the GFS, the 18Z GFS. Now, the people in this web chat, we go over these things a lot. We go over a lot of modeling data, so they're pretty savvy as to what's going on. And by the way, anybody, if you have any questions, I'm looking through here. I mean, the one question was, Tony, that Randy wanted to know if you think this could be the calm before the calm season before the storm. In other words, is this like the calm before the things really get cranking? Do you believe in such things, or do you just think we're in a little lull? Or what's the general perception that there's more to this season to be had, or are things really winding down?
That's a very interesting question, and the answer that I have right now is that I would say that I have good news and bad news. The good news is that this is the peak of the hurricane season, and the Atlantic itself is probably gonna have, I would probably one or two more big flares, and we're probably are seeing the next one. Then when we're heading to October, the Atlantic historically it starts winding down. There's a phenomenon that is called upwelling, and I know that the more savvy listeners, they have heard this term before. Upwelling happens when you have a deep layer of ocean water, and the colder water that is in the bottom starts moving up, and it starts displacing the warmer waters at the surface. So the temperatures, the sea surface temperatures in the Atlantic, they're going to start to cool down. Gradually, they're going to start to cool down. And the wind shear in the upper levels is going to start to increase. So when we head into the month of October, normally the Atlantic starts shutting down. That's the good news. The bad news is that, on the other hand, the Gulf of Mexico and the Caribbean, in late September and October, that's when they have what we call a second flare. So most of the activity historically in the second half of the hurricane season, it moves into the Gulf of Mexico and the Caribbean Sea. And if you go a little higher in that graphic that you're showing, I can show you exactly a little more higher. No, a little,
Oh,
one or two slides. Yeah, a little more higher. Go up, go up.
Which months? Oh, you want me up toward this?
The one that has the one that has the orange curve, it's like an inverted Gaussian bell.
Right here, the September?
No, you have to go high. Keep going. Keep going.
There we go.
No, the other way. Keep going up to the top of the page, towards the top of the page.
Right there?
That one right there. Number of tropical cyclones per 100 years. Okay. I think you went already.
Oh, we got a delay here. I'm hearing you in a delay, Tony. That's
yeah.
Okay. I'm like, wait a minute. I'm hearing you, but that's interesting. Okay, here we go. I've got this. I'm now where you want to be. You're just delayed 10 seconds. This is freaky. Okay. Anyway, so right there, right?
That one.
Okay.
Number of tropical cyclones per 100 years. That's the one. So the first peak that I was talking about is centered right around September 10, right?
Mm-hmm.
Now, the second peak that I mentioned, if you look further to your right, is around October 20th. That's the second peak that we normally see in the hurricane season. And unfortunately, that second peak corresponds to increasing hurricane activity in the Gulf of Mexico and the Caribbean Sea.
Mm-hmm.
Those are bad news because that normally combines with generally steering winds that can turn to the north and then to the northeast a lot of times. We saw that with several hurricanes in 2005. And we can talk, for example, about Wilma and the 1921 Tarpon Springs hurricane. They form in the western Gulf of Mexico and the Caribbean Sea in late October, and they headed straight for the west coast of Florida. So I guess that's the bad news in terms of the winding down of the season. It winds down in the Atlantic, but unfortunately, it still has a second flare on our side.
And Tony, what I'm showing now, even though I don't know if this whole 10 or 15-second delay thing is throwing me for a loop, but I'm now showing the 1921 track of the Tarpon Springs hurricane.
I see it.
And again, this is what I often tell the people, that it's interesting. The Weather Channel, which did one of those, doomsday shows, it could happen tomorrow deal, they bring it in in this general direction and then cut it hard as a trough picks it up. To me, this seems like a more likely scenario as lower pressure develops in October in the Southwest Caribbean, and it just sort of drifts north until the trough catches it and kicks it to the northeast. I mean, they're both obviously equally devastating, but it seems like this might be a track that's more reasonable than one. But then again, you could argue that what's going on there right now, if what will likely be Ophelia stayed very weak, it would likely travel in this general area, which is exactly what the GFDL is showing, and then eventually it would have an opportunity to gain strength, I guess. So, you know, I'm not saying that that's necessarily what the track is, although that is what the GFDL is showing. And by the way, I've got a couple of questions here. Laura's saying, what about Ophelia to be, if you will? What's the thinking? I mean, what I have said with that is if it stays weak, it will likely go more westerly. If it intensifies, it would feel more likely. It would be more likely to feel the mid layer upper level wind, the mid and the upper level winds, and in doing so, it would probably curve more around the ridge and go out to sea. It's pretty rare that a storm out here late September is going to have direct impact on the southeast coast.
Yeah, absolutely. I agree with you. And you hit a very interesting point there. I'm just going to mention it very quickly. I don't want to take too much time talking about it. But you mentioned the depth of the storm. In other words, how high, how tall is the storm? And that's very important. Actually, the master's thesis that I did in Hawaii to graduate was about something that we define as the steering layers. And one of the interesting results that we found was that definitely the size of the storm in terms of height, it's critical. Because like you mentioned, weaker storms, like tropical storms that are weak, they're not as tall as a big large hurricane. And the shallow the storms are, the more likely they're going to follow the lower level winds. However, as the hurricane intensifies and becomes stronger, it also becomes taller. And one of the things that we can remember is that historically, we've seen like in satellite pictures when they talk about historical hurricanes like Hurricane Hugo, like Katrina, even Wilma when it was at its peak. We always heard kind of like an interesting comment, especially from the astronauts in space. They'd say that storm looked like it was just pushing against the stratosphere, and it just wanted to punch through the stratosphere. And that's exactly right. The top of the storm is already against the highest levels of the troposphere. So like very well you said, the taller, the bigger the system, it's more likely that it's going to start turning towards the north and maybe into the northeast because it's interacting with a deeper, taller layer of winds in the atmosphere. While the tropical storms that are weaker, that are shallower, they normally tend to follow more the lower level winds. So if Ophelia remains as a weak tropical storm, it's more likely that it's going to keep following the lower level winds and have a more west-northwest track. And then at some point, if the timing of the trough is good, then it may pick it up. However, if Ophelia do become a strong hurricane, we may see that it's going to start doing that northerly turn beforehand. So the intensity is certainly going to be a key.
Yeah, I think that's just what experience shows us. And one other thing that experience shows us this time of the year, and someone just asked a question about this, is the GFS. Now, if you've been watching, and I will tell the folks at home, most of the time, anything past 8, 9, 10 days with the GFS, a lot of meteorologists don't even look at it because it's just fantasy land. Well, I will tell you, and somebody just mentioned the GFS bringing something into Tampa. Well, interestingly enough, what it's bringing in, I have not seen the 18Z, but I'm assuming it's the same. It's a similar run. Anytime from day 10 to day 14, it seems this time of the year to want to do that. But what you're looking at right here, this is that low. That is, yeah, that is Ophelia or TD, whatever. The GFS really doesn't appear to ever blow it up. And there's the ridge that Tony talked about, and watch what's going to happen. It's going to spin right around that ridge. But at the same time, look in the Caribbean. This is what the GFS has been doing now for quite a while. And if you watch, I'm assuming that that's exactly what yep, boom. So that's what they're talking about. Now, as ominous as that looks, the GFS has been doing this now off and on for the last 3 weeks. However, my point is, this is the time of the year, and Tony, I have no doubt you'll agree with this. This is the time of the year that this is where you expect to look. I mean, we showed that on climatology. If you go into early October and look at where things start popping, all you got to do is look at this map, because this map here shows that while there are still certainly some storms out in the Atlantic, look at the concentration in the Caribbean. In fact, let's zoom into this since I forgot. We can even zoom in a little bit. I mean, you look at this area right here, and this is obviously an area that bears close watching. So, Tony, when you see the GFS do what it likes to do, which is blow things up days 10 to 14, as ridiculous as it is looking out that far, there is some validity to looking in this area in October.
Absolutely. I would say not only there's validity, that is the area that we must keep all our attention over, because that's the sweet spot.
Mm-hmm.
For two reasons. If you look at the storms that form in the Gulf of Mexico, certainly they are close and they can become a threat. But for example, if you look at most of the points over the Gulf of Mexico in that graph that you have there, look at the time that they have from that red dot all the way into the Florida West Coast. Look at the distance. And now look at the dots that are all concentrated on the Western Caribbean Sea. Just that quick visual inspection tells you that the cyclones that form on the Western Caribbean Sea, they have more time over the waters. They have more, their lifespan is longer. And the longer the system remains over water, the better the chances it has to develop. So yes, the ones that develop in the Gulf, of course, we have to look at them. But it's the ones that are across the Western Caribbean, the ones that have more time to develop. They're going to be in contact with water the longer time. And actually, those are the ones that, if their timing is good with a trough, with a strong trough that is coming down from the Midwest, from Canada, those are the ones that have the time to develop, to become strong, and then if they time themselves with the trough, then they can do that sharp turn to the northeast, just like Wilma did, and just like the 1921 hurricane from Tarpon Springs did.
Well, the one thing that I've been looking down the road is that there's a pretty impressive cutoff low and a trough that's coming in next week. I was looking at it in the Euro, actually, and we've been talking about this for a while too. But I mean, let's see if the 18Z is showing it, because, and actually, well, look right there. Look at that developing right there before. That was a little interesting. There was even some talk of a spin up off the East Coast. The Canadian kept showing it right around the mid-Atlantic, a little something developing along a stalled out front. But you know, the questions that keep coming up, are there any other models that are predicting? Well, I have two questions, actually. One, and this is one that I think a lot of folks have asked me. You would think a storm could form in the Western Gulf and make a beeline straight to Tampa. There's no land in the way. It forms in the Western Gulf, it goes east to Tampa. But that doesn't happen. Why is that?
Well, there's one problem. For these storms in the Western Gulf, it's